goes now. He's going to get this one. He is. Look at that.
So some of you may be familiar with the story of Rory McIlroy, going on to play the same level as Tiger Woods, who he once idolised, he grew up idolising. And you may be wondering, what's that got to do with SOLIDWORKS? What's that got to do with what we're looking at here? Well, one of the reasons that I'm particularly passionate to be able to support you guys every day is because, in a sense, if you think about it, the golf club, the way that sort of enables the success for Rory McIlroy and allows him to play at that level, that's what SOLIDWORKS does for us as engineers and designers. So, as engineers and designers, we need the tools to allow us to do that. So what does a hole-in-one product look like? Well, strong enough that it doesn't fail. We don't get failures out in the field, get a bad reputation for ourselves. It's cost effective. It doesn't overuse on material, it's not overly complex, therefore it saves money. And finally, it's optimized to whatever it's going to be used for. So, how do we do that? How do we design products to be the very best that they can be? How do we engineer them so they don't fail? This is quite a lot. All Rory had to worry about was putting the ball in the hole. We've got all this on our plate. So one of the tools that we can use in order to do that is SOLIDWORKS Simulation. We've got a full suite of simulation products in SOLIDWORKS now. It doesn't matter if you're facing a buckling problem, a fatigue problem, a thermal problem, it's all in there, it's all ready to go. So what I'd like to do, guys, is I know some of you may not be all that familiar with simulation and how it works. I'd like to take you through a basic example of what we can do, and then from that, look at some of the more complex types of simulation scenarios, some of the more complex problems. So naturally here, we're developing a golf club, Rory's own golf club here. And I've designed it, I'm happy with it, but I want to check it's going to be strong enough. In other words, my main thing is I want to make sure it doesn't deflect too much. So I'm going to fix the handle, I'm going to apply a kind of nominal force to the head of it, as if it was striking a ball, and we'll see how we come out. I'm crossing my fingers here, it's around about the 25mm mark of displacement. That would be about right. With some of the fastest solvers in the industry, we don't need to wait long to get our results. And right away we can start seeing the stresses in this model and also start to understand, of course, the displacements in it. Now my displacement there is coming out as about 47mm. If you have a look at that, it's actually displacing quite a lot, more than I'd hoped. So what can we do with that information? SOLIDWORKS has told us, well, it's not really meeting our criteria. So here's what we can do. We can start a new design study. And in that design study, we can optimize this golf club in this case to our specific perimeter. Now what I'm going to do here, guys, I'm going to say, well, we're willing to go between 6 and 8 millimeters in terms of the thickness of the shaft there, so long as the displacement's less than 25 millimeters. And what I like, guys, is if you can imagine your product here, not the golf club, but your product that you're making, what perimeter do you want to optimize? Do you want it to move less, have less stress, be lighter, be cheaper? It's up to you. So we'll go ahead and run this, and right away you can see it pretty much batters through the simulation studies to arrive at our optimal value there of 7.2 millimeters. So when I click on that, as I'm doing here, and then we take a look at that back in the sort of design plot where we get those colours and whatnot applied to it, we can see it's now meeting our criteria of 22 millimeters. Finally, guys, I'd like to conduct a quick fatigue analysis. Sure, it's meeting my displacement criteria, but how long is it going to last? Well, let's set up a quick fatigue study. And this is all done in real time, it's not sped up or anything like that. And I'm going to run this for 100,000 cycles and see how we get on. Even your most avid golfer might not hit that. So we'll add the cycles in, then we've got the choice when it comes to material. If you're a real boffin, you can get into all the gubbins of it, specify everything, or we can let SOLIDWORKS take care of that. I'm choosing the latter. Not lazy, efficient. We'll run that, and right away we can see we're getting 13% damage in this area, and we can get a handy life plot to say, well, we're going to last somewhere in the region of about 700,000 cycles. Thanks for watching, guys. Although that's not strictly a what's new, I appreciate your attention and taking a moment to look at the power of simulation. And I'd like to close by saying, it doesn't matter if it's a thermal problem, if it's a buckling problem, a frequency problem, whatever you've got in your head, whatever you're facing, speak to us. We've got not only the solution to help you with that, but we as a team have got the expertise to help you get the job done as well. Alright guys, from there I'm going to pass over to Kieran, who's going to show us why getting involved with simulation in 2020 is the best time ever.
Thanks for that, Grant. So yeah, as Grant mentioned, we're now going to have a little look at the enhancements with simulation when it comes to SOLIDWORKS 2020 in there. Now again, we do have a wide range of them in there, everything all the way through from user interface improvements, just making things a little bit easier to navigate, all the way through to flow simulation at the end. But starting off with the user interface itself, there's some nice little additions when it comes to SOLIDWORKS 2020. The first one there being able to use the Shift-C in order to go ahead and collapse your tree. Now, to some people, it may seem like a nice simple thing in there, and we've long had this ability in the modelling environment. When it comes to simulation, this is one of those things where, dare I say, it really grinds my gears. That you have to go ahead and collapse everything down manually in there. So what we can now do is go ahead and do that at a click of a button. What we also have is the simulation evaluator. We can go ahead and check all of our setup before we even go ahead and run it, make sure it's set up just the way we want it. And lastly, again, a nice little addition, being able to delete a study out without actually loading the study up to begin with. Again, it's just efficiency in there, guys, trying to make things go that little bit quicker. But again, we've got a little example of this. So if we go ahead and jump into this simulation I've got set up here, and sure enough you can see my tree was expanded out, and just like that, I click a button and it's went ahead and collapsed. I can then go ahead and launch this simulation evaluator just by right clicking on my study name, and we can go ahead and check where my results have been stored for this study. Or what I can even do in here is point it towards a different results file if I wish. So if you've got multiple results files in there, we can now quickly and easily repoint those. Within here we can also go ahead and check the material that we have applied to our components, and one of the best ones is comparing that mesh volume with our geometry volume, making sure that our mesh is nice and accurately representing the model that we're trying to simulate. The last little bit is, as I said, being able to delete a study out without loading it in. As you can see, just by selecting the study and right clicking, it no longer loads up that information. Again, just saving that bit of time on a day-to-day basis. So again, just setting it up faster, making it easier to use. Moving on from that, we also have some little additions when it comes to beam elements. Now, for any of you guys who use simulation at the moment, I'm pretty sure you're aware of the the solid elements, your shell elements and your beam elements when you're trying to simplify things down a little bit. However, we're going to stick with the beam elements for this one. And with 2020, we now have the ability to go ahead and apply these thermal conditions in there, whether that be a simple static stress analysis, want to apply some temperature in it, or whether we want to carry out a full-blown thermal analysis on that, or even take it that one step further and create a stress analysis from your thermal analysis. So again, we'll have a little look. So as you can see, I've got this little study set up in here, and what we want to do is go ahead and apply a thermal load. So the way we're going to go ahead and do it, I'll load up my thermal study that I've got. Just going to add it in as we would for any other load in there. So again, just right click on my loads and you'll see we have the temperature option. Now this is nothing new, but what is new when we go into this tool is we now have these two additional options in here where we can go ahead and apply this thermal load to either the beam profile or even just a single joint within your simulation as well. Moving over to the full-blown thermal analysis, you can see we also have the options for our heat power, radiation, convection, and so on as well. So we can then go ahead and start to view our results and all of those beam elements that we have set up. Last but not least, we can go ahead and pull those thermal results into a static analysis to go ahead and look at those deflections in there. Again, for example, this OMAX waterjet cutter, we need to have some pretty precise deflections on it. We need to know what those are, so we can now go ahead and simulate them using our beam elements, speeding up your process. So again, we now have more support for some real-world conditions in there. Moving on to the next one, we've actually got two included in here. One of them being that we can also go ahead and manipulate our mesh, whether we use our draft quality mesh or our high quality mesh. So many of you might be familiar by now that we have the availability of this draft quality mesh, where we can go ahead and use it and essentially check our setup, things like that, without having to sit around and wait for the solution to happen. But now what we can go ahead and do is specify individual components to be either high quality or draft quality in there. So we then have precision at the locations that we want without wasting time on areas that we're not particularly interested in. On top of that, we're also going to have a little look at this new distributed connection type that we're talking about, and that's relating to our bolt connectors and pin connectors. But we'll get into that in just a second. Starting off with the mixed meshing that I was talking about, we can go ahead and select our whole folder of parts and apply our higher draft quality to all of those parts in there. Or now with 2020, we can go ahead and apply this draft quality to individual components in there as well. So again, speeding things up with the analysis. Moving on to the distributed connection type, just going to go ahead and edit these bolt connectors that I have in here. And when we go ahead and open those up, you'll notice that we have a new little option here, this connection type. I'm going to pop that onto distributed. Go ahead and have a look at the results when we go ahead and do that. And what you'll notice is we no longer get these stress concentrations round about those bolt connections. So it's now more accurately representing how those bolts would be represented in real life. Now that little example doesn't really do this one justice, so what I have is another little example of it. What we have with this one is 4 different setups. So we've got one with fixed holes, we've got one with hinged holes and a virtual wall to stop it from sliding anywhere. We've got one using foundation bolts with that original rigid connection which was default up until 2020. And we also have that new distributed connection in there as well. Now just go ahead and prove the setups that I do have. I'm going to have a little flick through them. So you can see I've got my fixed holes in this first study. Go along to the next one. We've got our fixed hinges with a virtual wall, as I suggested, to stop it from sliding anywhere. Go into our third study here. We've got those foundation bolts, and if we just edit one of them to have a little look, you can see that we're using that rigid connection type in there. As I mentioned, this is a default up until 2020. And lastly, we have the same setup, except this time we're going to use that distributed connection type. Once we're happy with all of our setups, we can go ahead and click OK to that. And then we're going to go ahead and view all of the results together in order to compare what the difference is. Now, in order to do that, we're going to make use of the Compare Results tool. we can quickly and easily go ahead and select each of the stress plots from the setups. And then my graphics area divides up into those 4 quadrants, so I can see all of those results at the same time. Now, not too sure for you guys at the back how the numbers lie with that, but what's actually happened with this, with the one down at the bottom right with that distributed connection, our peak stresses are actually a lot lower than all of the other setups. Because it's now distributing that load at the connection, it's now more accurately representing those bolt connections as we would see in real life, neglecting those little stress concentrations that we can see in all the other stress plots in there as well. So again, a great little enhancement for simulation. Moving on from that one though, we also have a little addition for our non-linear studies as well, whether that be a static or a dynamic. We can also go ahead and calculate out the free body forces for individual bodies in there. Now, to understand this one a little bit better, we've got a little example here. And what we're going to do is go ahead and view our resultant forces as we usually would with any study. And we're going to use this free body forces option. Select the components that I'm interested in. And what I could even do is go ahead and select the time step that I'm interested in as well. And then at a click of a button, we now have all of these free body forces that I'm interested in for these individual components ready on the screen. So we can now start to dig into our results a little bit deeper to see exactly what's going on with them. So just to sum up the simulation section of it, we have our simulation evaluator, so we can go ahead and check our setup. We've got those thermal beam conditions that we can go ahead and add in. We've got the mixed quality meshing, again just speeds up our simulations a little bit better. And we also have those distributed connections. Now, I'm not completely done with simulation here, because what we're going to do is move on to one of the other simulation products that we have, which is SOLIDWORKS Plastics. Now again, with 2020, there's some great new enhancements with this one. Up until 2020, what we'd have to do is we'd always go ahead and have to mesh our model before we go ahead and define any of our domains or boundary conditions in there. But now we can go ahead and apply these directly to the 3D model. Just to see this a little bit better, again, it's a little example. So as I mentioned, usually we would need to go ahead and mesh this component first of all. But what we're going to go ahead and do is show you the new method that we can go ahead and use. So if I go ahead and set up my new study that I want to use, and what I can do is go ahead and apply all of my domains to my model. So that's essentially all of the physical features of my plastic simulation that I want. Again, just a right click of a button, we can go ahead and assign them from a tree. Likewise, when it comes to our boundary conditions, so these are essentially the simulation parameters, what we try to simulate. Again, we can go ahead and apply this directly to the 3D model, whether that be the injection location. You can go ahead and select it from a little split face that I have there. You can also go ahead and apply that clamp force. And finally, we're going to finish this one off with the cooling channels as well. So we're going to go ahead and cool this mold down to cool that part down a little bit quicker. And again, you'll notice that all of these parameters are getting defined directly onto the 3D model, and we've not even begun meshing it yet. Now, the great thing about this enhancement is the fact that anytime you come ahead and change your model, all of these parameters automatically now update with your model as well, whereas previously we need to go ahead and come back in and define those again. This time, it's all done automatically for you. So again, just allows for that faster setup, and it's more associative with our geometry. Now, just to wrap up this little simulation section, we're going to finish it off with some flow simulation. Now again, we have some great enhancements here, it's not being left out, and the first one I want to look at is this altitude option that we have. Now again, usually what we do is go ahead and set up our pressures and our temperature, or our default pressures and temperatures in our study. But now we can go ahead and define this simply by defining the altitude that we're simulating at. And as you can see, we can go ahead and define that from a nice little graph that you see on the right hand side. So when we go ahead and define this altitude, it automatically picks up my pressure and my temperature for me, just making it a bit easier. We also now have the ability to use fan derating in there. Now, as most of you might know, if you're used to working with fans, they don't often actually work at maximum capacity. The reason being is we want to try and prolong the life a little bit, and we even want to get rid of any noise that's coming from them if we run them at maximum capacity. So now we can go ahead and take this into account with our simulations as well. We can now incorporate this derating factor in there in the setup. We also have the ability to use logical expressions and formula dependency. Now, I can assure you that's not a one that rolls off the tongue very easily, but I'll explain it. With this one, we can now start to go ahead and control some of our inputs within our simulations, depending on some goals that we've got set up, whether that be a heat source that we've got in there, and we want to go ahead and vary that depending on one of the goals. And what we can go ahead and do is start to use our ifs, ands, and ors statements in order to define these. So if your goal is below a certain value, we no longer want to use that heat source. If it goes above it, it turns on. That sort of idea. And the final little one here is this heat exchanger in a porous medium. Now, when we're talking about heat exchanger, basically, as it suggests, just heat exchange through the model. And the way that this one works is that when we have our cool fluid, which is our simulation fluid in this case, we also have a virtual fluid present, and all that's doing is essentially adding heat into our model throughout the porous media as well. So again, it's always been within flow simulation, but it's now been added in with incorporation of porous media as well. So again, we've got some powerful new enhancements for your complex flow simulations, getting a bit more realistic with them. Now, there's one last little section that I do want to cover, and it's a nice little addition. For any of you guys that currently use a network license, up until now it can be quite tricky trying to pull the correct simulation license that you try to use at any time. But now with 2020, we can now go ahead and do this using a simple little drop down, where we can then go ahead and select the exact license that we want to use at any time, whether that be a SOLIDWORKS Premium, a Simulation Professional, or a Simulation Premium. So again, you can go ahead and allow the more advanced tools to someone else if they need them, while you just go ahead and use some of the more basic tools if that's all you need. But that pretty much covers the simulation enhancements for 2020. The next little bit that we're going to look at is the future of CAD, and for that I'm going to pass you over to Craig.
Alright, thanks there Kieran. So what I'm going to look at is what I've titled as the future of CAD. What I don't mean by that is something that's coming out next year or 2-3 years down the line. It's things that are actually available to you today or maybe tomorrow when you're back in the office. So we're going to look at some enhancements to eDrawings, particularly eDrawings Professional, ways that we can export any of our existing SOLIDWORKS parts or assemblies to virtual environments, or if we want to use augmented reality instead, as well as looking at an add-in inside SOLIDWORKS referred to as Mindesk, and mentioning some of the other kind of VR capabilities in there as well. So with eDrawings Professional, it was added in 2019, last year, the ability to open your models in VR. That was in a beta stage. It was a little bit buggy if any had actually tried it out, but in 2020 that's now kind of full released with a number of extra capabilities added in there as well. So I'll go through some of those enhancements we've got now. Obviously, VR in eDrawings Professional enables users to explore their model in a one-to-one environment with a number of enhancements over last year's release, and it allows you to put on a headset such as a HTC Vive, Oculus Rift, put them in your headset and start walking around your model. Opening up your model in VR is pretty easy, it couldn't really be easier. You select File, Open in VR, pick your native SOLIDWORKS file, hit Open, stick on your headset, and then you're good to go. In eDrawings 2019, it's had some improved support for things such as transparency, full anti-aliasing and ambient occlusion to make things look a little bit more realistic. We can change things such as the scene or the sky, as well as the floor, changing the scales, the light and intensity as needed, make it a little bit brighter, a little bit darker, including shadows and phasing the horizon to get rid of any sharp borders around the outside. Then we can zoom in our model and see them as we are. So eDrawings Professional 2020 has those number of enhancements over 2019. if you're giving it a go, using the controls as well, the controls have also had a number of updates. So particularly you can automatically create an exploded view, so you don't have to have pre-created an exploded view. With the click of a button on your controller, it will automatically create a radial exploded view. And then you can go around picking up your parts. So you can pick up one part of your model, even make it bigger, smaller, rotate it a little bit, and place it somewhere else. The one that I quite like is walking around the telescope model we had last year, picking up a monitor, make it a little bit bigger, place it back down my desk and go, yeah, I want a bigger monitor, that looks a little bit better. So we can see those changes quite quickly in there. If we want to make it look like our models in the correct environment, if any have like a 360-degree camera or an app on your phone that can create 360 images, you can use that as your scene, so it actually looks like your model's in your workshop or in your office or meeting room, that sort of thing. So eDrawings Professional 2020's had a number of enhancements, and if you are wanting to give it a go, we've got that obviously out in the corridor when you walk in. You can have a go at that during the lunch break, and I would highly suggest that if you do get the chance. SOLIDWORKS Visualize 2020 also has a number of enhancements. One of them is the option to export to the GLTF format. Now I'm going to talk a little bit more about exactly what that format is and where we can put that in the next slide, because we can do that from SOLIDWORKS as well. But Visualize 2020 allows us to export that format but in a higher quality, because we're actually creating a render of our models. We can also in 2020 use new IES light profiles, so we can download them online to give our renders more realistic lighting. Something to where if you're familiar with things like kind of ray tracing with modern graphics cards, you'll know that you want to try and get the most realistic lighting possible to mimic real world conditions. Also, if we have instancing in Visualize, so that's where maybe we've got a lot of component patterns, circular patterns, linear patterns, whatever it may be, we've got multiple of the same component over and over again. We don't have to render every single one of them out completely from scratch. You can almost kind of reuse some of those renders a little bit, just to speed up the rendering times and reduce the load on either your CPU or graphics card, whichever you're using for rendering. We've obviously been able to have any of our parts, assemblies, drawings or other files inside the PDM Vault, but now in 2020 you have native PDM integration inside Visualize, so you can keep any of your kind of animations, pictures, renders secure inside a vault, just to try and stop any of your nice looking renders kind of leaking online. You can keep them secure inside your vault with all the kind of revision control and all that comes with PDM. Talking about that GLTF format that I mentioned, in SOLIDWORKS 2019 there was a beta option to export models to either the GLB or the GLTF format using the SOLIDWORKS XR Exporter. That's still there in SOLIDWORKS 2020, and also it's included in Visualize to get even more high looking images and renders. But where can you actually use those outputs? If you want to go to the top end, you can export them to programs such as Unreal Engine or Unity. And we've got an example of that out on the kind of street area out there, where you can take models from SOLIDWORKS and export them into Unreal. So if any of you have been on a SOLIDWORKS Essentials course, we've got a little room set up where I've put in some of those models. We've been putting a little bit of fun, things like kind of bowling models, and all of them are created inside SOLIDWORKS. And those can have full-on collision detection, so things will collide when they contact other models. They've got gravity and physics in there, so if you throw something up, it'll drop, all of that. If you want to be a little bit more simplistic, you can actually import them into things such as Facebook. So you can export to GLTF format, stick that in a Facebook post, and you can quickly look around it on your phone. It's easy to show customers, or you can insert models into a PowerPoint as well. What we also then have is a VR add-in for SOLIDWORKS referred to as Mindesk. Now that's built into SOLIDWORKS as a native add-in, so what you can do is you can interact with a model with a VR headset, and you can start to change things like the transparency, exploding your model, moving things around, so interact with any of your mates that you've already created in SOLIDWORKS, and you can start to make changes on the fly and you'll see them update in real time in VR. So I've got a wee example of how that would work. So Mindesk, being a SOLIDWORKS add-in, is turned on the same way as any other add-in. Selecting our add-ins bit, scrolling down, finding Mindesk, and then clicking a little box to the left to turn it on, or the box to the right to turn it on every time we open up SOLIDWORKS. That'll then add in a little command manager tab up at the top, allowing us just to get starting Mindesk, and then we can change a couple of the settings depending on what exactly the type of VR headset it is we're using. get the orientation, the kind of starting position of our model the way we might want to. And normally I would drag SOLIDWORKS to the left of my screen, drag Mindesk to the right half of my screen, just so you can see what the actual person with the headset's looking at as well. With one controller you can control the transparency with a little slider, so you can have it fully transparent or not. The other controller will create an exploded view, and rather than it being just similar to SOLIDWORKS where it will be fully exploded or fully collapsed, it's got a little slider so you can choose how much that's exploded by, and then you can combine the two of them so you can have it partially exploded and partially transparent using a combination of both controllers. If you want to, you can also then use normally the trigger on the controls to start to grab any of your parts in the model. So obviously I've got it so the kind of gearbox starts to rotate, which rotates the fan blade, so I can just grab that and start to move it, and I can do that in the virtual environment or inside SOLIDWORKS. Since I can create an exploded view, why not make sure that the gearbox and the inside components are working? So I'll explode it out a little bit, grab one of the internal components, try rotating that, and that obviously rotates the fan blade as I would expect. Now anyone in SOLIDWORKS that doesn't have the headset on can then start to move that fan blade themselves, or they can even make changes on the fly. So if I want to say, it looks quite good, but how about we stick a blade on that has, or a fan that has 3 blades maybe, or can I change something from being red to blue? The person in SOLIDWORKS can just make those changes, and the person with the headset will see that update in real time. And you can see that in that kind of one-to-one scale and interact with your model. And if you've created any animations inside SOLIDWORKS, you can play those animations, so you can have all the animations nicely moving around, and a person in the headset can start to move around that. In an upcoming update, they're also going to add in the ability where in the actual VR headset you can make those changes without even needing someone in the SOLIDWORKS application. So the headset on, you can just start drawing your sketches, doing your extrudes, revolves, whatever that be, actually creating the 3D geometry from there. One other thing worth mentioning is if any have actually been to our office in Larbert, we've actually got a kind of VR room created. We've got the kind of state-of-the-art wireless kind of headset set up, modern furniture, all that sort of thing, so you can sit comfortably, someone can stick on their headset, and then they can interact with their models, see what it looks like in VR. And you can bring in customers or clients to use this room, so you can start to show people what their models and their designs might look like in kind of VR, and it makes it much more immersive rather than just looking at it on a laptop or something with eDrawings trying to get a preview. It makes it more realistic, and you can use any of those applications that I mentioned, so whether it's eDrawings, Mindesk, Unreal Engine, or other programs as well. Then there's a quick wee 20-second video. We've just got myself walking around one of the rooms. I'm actually measuring what the height of the ceiling is in a couple of the different rooms. And then a wee 10-second video of me using Mindesk inside SOLIDWORKS with a barbecue. Didn't quite have any burgers modelled up, so I just try to pretend I'm sticking the controls on, turning up the gas, closing the lid, that sort of thing. So just showing us how we can interact with the mates that I've already created inside SOLIDWORKS. And if you want to use the room yourself, you can obviously get in touch with us. So that's just some of the enhancements that are there for things such as VR, augmented reality, that sort of thing, that are going to start getting more and more prominent as CAD goes on over the years. To talk a little bit more about how some of the CAD is changing, the now and in the future, I'm going to hand it over to Alex, who's going to talk a little bit about the 3D Experience platform.
So lots of technology. We're all used to technology. We're all used to all this kind of high impact that it has on all of our lives. But what I want to talk about is business collaboration. How we actually communicate with our colleagues, with our suppliers, with our customers. Just some tools that have been developed by SOLIDWORKS Dassault to help with some of that stuff. But before I talk about how that could work, it's interesting to look back at how we used to collaborate, how we used to work, especially in engineering and design teams. So, hands up, anybody who remembers that kind of image. Drawing boards. So my background is in shipbuilding. I worked at Yarrow Shipbuilders in Glasgow, which is now BAE Systems, and this was commonplace. The collaboration that was done at that time, you basically collaborated with one person, your boss. You created a drawing, you gave that drawing to your boss, and he did something with it, and then if you were lucky, he came back and said, "Well done." If you were unlucky, you came back with a thing that was full of red lines and saying you have to fix all these problems. But the collaboration that we had was fairly limited. We had a very kind of linear approach to design. You know, something got designed, it was passed to manufacturing, it was then over to sales, whatever. Nothing was really happening at the same time. What's interesting, when I saw this photograph, it amazed me. I don't think I've ever seen a guy actually lying on a drawing board testing for a drawing. Although I did see a few guys hiding behind them to sleep. But anyway, that's you know where we used to be. So we were in a very kind of bad kind of area of how to work together. Everybody did their own thing and passed it to somebody else and forgot about it. There was no real connection with everyone. Things have moved on a bit. So we've now got computers, we've got laptops, we've got email systems, we've got Facebook, we've got WhatsApp, we've got LinkedIn, all sorts of things. So we're all fairly familiar with the technology that's there. We've got social media, you know, most of us are familiar with how that can work, and again, how that can help to bring groups together, to share information, to share stories, to share images, etc. But how do you apply that to a business? How could that work in a business? One of the issues that we have at the moment with the way that we work is we rely heavily on email. So if we're trying to share information with someone, it might be some drawing information, some design information, it might be with a client, a customer, someone internal. It's all done in emails and trying to find things, and then what attachment and attach the stuff to it, and what version was it. And the whole thing, in essence, just becomes a mess. Messages get broken, no one's really sure what we're talking about anymore. So the whole thing just becomes a girdle. The reality, the benefit, the thing we really would like to have is some way of communicating, which is online, because we're kind of all now used to communicating online. We want it to be secure, so whatever we put on that online community is in a secure environment. No one can access it without having the correct access. We can control it, so we can say people can have access, but here are the things that we can do when they are able to access it, here are the things that they can't do. And effectively provides us with a tool that we can use to much easier collaborate with everybody, all the stakeholders. You know, as I said, colleagues, customers, clients. It doesn't have to be internal to the operation. Which is what brings us to something called the 3D Experience Platform. 3D Experience Platform provides one portal where all of that information can be held, as opposed to having it in different portals, having it in a Facebook, or having it in a WhatsApp, or having it. It's one portal that allows companies, businesses to collaborate both internally and externally. I'm going to show a video here which is just the entry level to the 3D Experience Platform, which covers a role which is called Business Innovation. This is in effect just the start as to where you can go from here, so that you can start by creating some friends that you can attach to a community. You can start to share information with those people, and you can start to see the power once you start to connect the portal to a design system such as SOLIDWORKS. Easier to see this than it is for me to explain it. There's a couple of things in this video that I'm going to correct once you've seen it. It's about 6 months old, so a few things have changed since then. But anyway, 3D Experience Platform. Hopefully this video will run.
What if you could innovate faster, collaborate better, and connect all of your data in one place? With Dassault Systèmes' 3D Experience Platform on the cloud, you can. And 3D Experience Social Collaboration Services is your gateway to this unique online business platform. It allows you, for the first time, to upload your SOLIDWORKS data onto the cloud and digitally connect all stakeholders. The business intelligence, collaboration, and marketplace functionalities of the 3D Experience platform allow you to manage your product development, empower innovation, and make your business thrive. And you can do this anytime, anywhere, and from any device. 3D Experience Social Collaboration Services helps you save time and money and innovate faster in 3 key ways. business innovation on the cloud. Store, share, and collaborate online with internal and external teams, including employees, clients, vendors, and suppliers. Facilitate innovation and collaboration within your company. Track business insights and build dashboards for any type of data or information. Communities. Get answers. Learn more and connect with the global design and engineering community. 3D Experience Marketplace. Access a vast and qualified network of industrial service providers. All of this is included with a SOLIDWORKS subscription. It just takes one click to get started. 3D Experience social collaboration services, enabling SOLIDWORKS users to leverage the power of the 3D Experience platform.
So as I said, this is the entry level to the 3D Experience platform. The thing I need to correct is it said in the video that this is all free as part of your SOLIDWORKS subscription. It was free 6 months ago. Sadly, things have moved on, so there's now some costs involved. What I'd like to do now is to hand over to Tom, who will take us through a real life example of a company that's actually using the 3D Experience platform and the benefits that they've achieved by going down that route.
Thank you, Alex. Good morning, everyone. My name is Tom Wallington. I work for SOLIDWORKS, and I support our resellers across the UK and Ireland. Pleasure to be in Glasgow this morning. So, yeah, great introduction there, Alex. So I'm going to talk you through the 3D Experience platform and exactly what this is. So the 3D Experience platform is very much a business platform where people and teams across the whole of your organisation, not just the engineering department, can share data, communicate and collaborate with one another. Now, one of the great things about the 3D Experience platform is that it is 100% cloud-based, and the entire infrastructure is taken care of by us, by SOLIDWORKS. So you don't need to invest in expensive servers or IT resource to maintain and upgrade the system. One of the other things about the 3D Experience platform, all of us use a whole host of applications to communicate with each other on a day-to-day basis within our professional lives. So whether that be WhatsApp or Outlook or Dropbox or eDrawings, whatever it might be, you can take all of those applications and put them, or not specifically them, but replace them with the 3D Experience platform. So you have full traceability across your organisation. So I'm going to share with you the experience of one of our customers, Icon, who adopted our platform. And it's a really interesting story, Icon. So the company was founded when the MD had a really unfortunate accident while snowboarding and broke his back. But he was determined for this unfortunate incident not to prevent him from pursuing outdoor activities. So he set about designing a wheelchair which would allow him to get to those hard or difficult to get to places. And the Icon Explorer was born. And after today, I was just looking on their website and you can have a look at the product. So like all engineering teams, there were a number of people involved in delivering this product and getting it to market. So the first person, Pete, is the project manager. So Pete's main responsibility in life is to gather feedback from customers and then make sure that that feedback is input into the product development. Once he's got that feedback, what he wants to do is assign individual tasks to other team members, and most importantly, he's also the person in charge of approving any changes that get made. Don, the designer, is very much your typical SOLIDWORKS user. So he uses SOLIDWORKS on a daily basis. He's also responsible for communicating with the rest of the team. So he needs to have constant access with the other team members, and he needs constant access to the data, and he occasionally works from home. Now, Debbie, similar to Don, in the fact that she uses SOLIDWORKS, but Debbie's focus is more on the technical publication, sales and marketing content. And she uses SOLIDWORKS Composer and SOLIDWORKS Visualize to produce this documentation. And finally, Adam is our geeky simulation engineer who is responsible for optimizing designs whilst also ensuring that they don't break. He also lives in Ireland. So going through those different roles, it all seems quite straightforward, quite simple, but actually when you take a step back and think about the emails and the messages and the conversations and the data which flows, even in that small team, it actually becomes quite overwhelming quite quickly. So what we want to walk you through today is how we can manage all of that interaction through the 3D Experience platform. So let's take a look at Pete, the project manager. So he signs in to the platform, remembering it's cloud-based, so just by a simple login. And the first thing that he sees is a dashboard where people can post pictures, they can write comments, and generally interact with one another. So I suppose you could say it's a little bit like Facebook. However, this is much deeper than that. So for the engineers in the room, which I'm sure there are many, you also want to be able to get access to your CAD data, your SOLIDWORKS data. So by quickly searching, you can find the files and then drag and drop into 3D Play, which for anyone who's used eDrawings, it's exactly the same, even better, I should say. So Pete, the project manager, has taken a look at that file, he's spun it around, and I think from what he's seen so far, he's impressed, it looks good. So back into the community, and he's going to write his first comment. Yep, it looks good. Let's go ahead and design our first prototypes. And he posts that, and everybody who has access to this dashboard can see that the project is progressing. So top of the screen, this is our design community. Let's fast forward a little bit, and our first prototypes have gone out to market to our early testers, and they've begun to give us some feedback on exactly what they think of the design. So in our feedback community, which you can open up to customers or suppliers or anyone external to your organisation, you can begin to gather their feedback. And what I really like is the ideas pipeline. So you can actually categorise people's feedback. And I think this is really great because your customers can see that you've taken the feedback on board and you're actually progressing it through your workflow. So not only that, we can actually ask specific questions to our feedback community. So it might be anything. What did you most like about this product? What do you want to change? And in this example, from a survey poll that we've ran, weight is the biggest concern of our feedback community. So that's great. We now know what we need to change within our product. And we've taken that and we're now back in the design community and we've gone, look guys, based upon the feedback, we have discovered that weight is the biggest issue. Let's go forward and change that. So now we've got that, we need to feedback that information to our team. So back into the 3D Experience platform, and at the top here, we're going to go into our project mode. So this is very much a project planning tool. And within this tool, you can start to build up your project, add in team members, as we're doing here. So remember our personas from earlier, they're now going to be added to this project. And as soon as we do that, they'll receive a notification to say, great, you're now part of this project team. And as you can see, it's almost like a Gantt style chart here, and we can begin to add tasks and assign them to individuals. So in this case, the 3 tasks we're going to assign to our team members, we're going to get Adam to run some analysis to try to minimize the weight of the product. We're going to get Don to implement those changes based upon the analysis. And we're going to get Debbie to update all of the sales and marketing content so that it reflects the changes that have been made. So when Don goes into the platform, as you can see, it's a slightly different view. There's some more engineering content. But as we can see, he's received a notification from Adam in an internal messaging system. Adam, our analyst, has said the front suspension looks a little bit over-engineered, Don, and he says, okay, great, I've got it. I'll go ahead and make the changes. So he moves the task on our task scheduler from to do to in progress and updates everyone else in the team that he's working on this. So now for the first time, we're actually going to go into SOLIDWORKS. But as you can see, we don't need to come out of the 3D Experience platform in order to launch our SOLIDWORKS. And here we are, a screen that all of us are very familiar with. So on the right-hand side, this is our window into the 3D Experience platform. So what we need to do is go and find that front suspension so that we can work on it. But we need to make sure that we've got the right file, of course. So we can check the properties. And then we can also check whereabouts that file is used. So confident that it's got the right file to work on, it can now open that up with all the associated parts and components, and there it is, our lovely looking front suspension. So let's take a closer look now, and anybody who has used PDM or any kind of data management system should be familiar with this type of information, and that is exactly what this is. So we've got the files and how they associate to one another, we've got the revision, and we've actually got the maturity state, or we could call that a workflow state. So let's go ahead and make the changes to our front suspension. So what we want to do is identify the components within this part that we want to change. And we're going to reserve these so that no one else in our team can do anything to them. Essentially, we're checking these out. And then what we're going to go ahead and do is reduce the weight of that part. Now, what we need to do, of course, is we've just changed the file quite dramatically. We need to make sure that the rest of our team members are notified of these changes. And as you can see on the right-hand side in our task pane, so we've got the green key, which means either reserved or checked out. But there's also a symbol on the status, and this alerts us that some changes have been made to the file. So we want to save the file, and it's important at this stage to remember that there's two copies of this file. There's one that's downloaded onto your desktop, and there's another version, another copy of that uploaded in the cloud. But we need to make sure all the time that those two are synchronized. So what we've gone ahead and done there is we have changed the revision. So those components that we're working on have now moved from A1 to B1. So we've up-revved them like you would in any other PDM system. Right, so what we want to do now is we want to change the workflow state from in work to frozen. And what we do by going through that process is effectively we're moving these files through our workflow. So these files will now go from Don to Pete, the project manager, for him to approve. So we've let our direct team know that we've made changes to this file, which is brilliant. But remember, this isn't just an engineering system, this is a business system. So we've completed the task to say, yep, it's been done, fantastic. But what we want to go ahead and do now is notify people who aren't just in the engineering team, but they might be in purchasing or any of the other departments about the changes that we've made. So within 3D Play, which is very similar to eDrawings, we can create this markup and put thoughts and get everyone else's opinion about what they think. We could also post that back into our feedback community and see what they think of the changes that we've made. So Pete's had a look and gone, great, nice work, Adam. So Debbie and Adam, please go ahead with your tasks. So it's now time for Debbie to get in on the action. And remember what we said before, Debbie's responsible for sales, marketing, technical publications. So again, like the others before her, she goes into the 3D experience, actually she goes into SOLIDWORKS with the task pane into the 3D experience platform on the side. And for the most observant people in the room, what you'll notice is that our front suspension is not the most up-to-date version. It's not reflecting the changes that were previously made. We can also see by the symbols in the status that changes have been made. So before Debbie goes ahead and does anything, she needs to make sure that she updates this with the latest revision. And that's exactly what she does there. So there's a plus symbol next to front suspension that says there is a new revision available on the platform that you need to download to your local desktop. So it's quite simple. All we have to do is go down to replace by revision option and the part updates. So now that she is assured that she's working on the correct file, Debbie can go ahead and she can produce a instruction manual or maybe some renders or whatever it is that she needs to do for the project, and she can put all of these files quite neatly into a favourites folder. So there's no need for her or anybody else to go searching through the system. They're packaged up nicely in a folder and easily accessible to everybody. So we've got a mixture there of files. We've got a PDF, may have some videos, whatever it might be. And we can actually take those files, put them within 3D Drive and view them. We can do this, or anyone else in our team can do this. So she's happy with what she's produced. And again, what she wants to do is post this, or post these files back into the feedback community so that everyone else within the organisation can comment on what she's done. Okay, so back into our task scheduler. Now that she's completed her task, she can move it along. And I don't know if you've noticed, but there's 3 pictures of people. Those are the people within the project. So as soon as she moves that across, they all get notification. Now it actually goes a little bit deeper than that. When you click on these within the 3D Experience platform, there's a lot more depth than you initially think. So you can actually attach files or the deliverables to those tasks. So when Pete, the project manager, receives a notification to say Debbie has now moved that to done, he can go in here, click onto the task and get the access to the files. So it's just making everything so easy to search and find, and saves you a lot of time in the process. So just a quick review really of where we've come from and what's happened. So we've gone to that feedback community, we've got their feedback, and we've assigned tasks to the 3 members, all the time communicating, collaborating really quickly, really easily. And I hope you can see the benefit of using one system to encompass all of this, rather than the disparate systems that you might currently be using. That's it for today. Whistle-stop tour of the 3D Experience platform. I'm sure you've got lots of questions. I'll be around for the rest of the afternoon, so please come and grab me, and I'll be happy to answer. Thank you. Cheers, guys.
All right. Thank you there, Tom. So I'm not really going to talk too much more about 3D Experience platform. I just want to put up just kind of 2 or 3 slides just for 2 or 3 minutes to mention 1 or 2 of the other things, particularly about design and work. If you're a designer in the room, that you might be a bit more interested in. So one of them is talking about XDesign. So XDesign is pretty much the equivalent on the platform of SOLIDWORKS itself. So when we're there, we can create new parts, or we can edit any of our existing parts inside XDesign on the platform. So we can do that on any device, anywhere we are. A lot of the tools in XDesign are designed to be familiar for those that use SOLIDWORKS already. So a lot of the sketch tools you'll recognise, the part design tools, your extrudes, revolves, cuts, delete face, all of that. And even surfacing tools, so creating your extended surfaces, railed surfaces, knitting them together, trimming them, all of that sort of thing. Then once you're finished making the parts, build up your assembly, insert your components, make them up together, create maybe your component patterns, mirror them, those sort of things. And then at the end, maybe even apply a basic bit of simulation, apply a couple of forces, that sort of thing. Then we can use our other apps if needed to create more advanced simulations from there. If XDesign doesn't quite do the job for us, we could potentially look at XShape. So that's where we can start to look at some sub-D modelling techniques to create our part. So if we wanted, we could start to create a new part by almost creating a basic shape, create a kind of mesh almost like around that, and then any of the points of that or the faces, we can start to just kind of push and pull them freely as we want. And then again, some of those icons are designed just to be familiar with us. We don't have to just use XDesign or just use XShape. We can show, as Tom mentioned, jump back and forward from SOLIDWORKS, so we can use a combination of these if we wanted. Then obviously any of the data that we create, we might want to keep that secure on the platform as well. So any of the files that we put on the platform will have the file hierarchy there, and it will have the revision numbers in there. So we'll have a revision A, revision B, C, so on and so forth. We'll also then have the revising or reserving files. So similar to your checkout, we can just say that I'm going to work on this particular file so someone doesn't come in and make changes when I'm trying to edit a particular part. Then obviously we have an example of a kind of workflow that we can start to push our files along a workflow, and again you can customize that to meet your own company's needs. So that's it for the 3D Experience platform. Thought I'd keep it nice and short. I think Alex and Tom both did a great job at explaining all about the 3D Experience platform. So we jump a little bit back to SOLIDWORKS. I'll hand it to Kieran, who's going to take us through some stuff in electrical.
Thanks for that, Craig. So yeah, now looking at SOLIDWORKS Electrical, so jumping back to one of the SOLIDWORKS products themselves. Now we've broken this down into three main sections for you. So we're going to have a little look to begin with electrical schematics and some of the enhancements that came with that. We're then going to follow that up with electrical 3D and routing. So if we've got our schematics built up, how can we go ahead and pull those through to the 3D model? Or even if you don't have electrical, how can we just go ahead and use the routing tool to go ahead and route up your electrical connections? And finally, going to wrap it off with SOLIDWORKS PCB as well, and how that can interact with SOLIDWORKS PDM as well. But starting off with the schematic side of things. Now, a few of the enhancements that we have with electrical schematic is we now have the ability to create custom user right profiles in there. Now, up to date, what we've had is 5 different options that we can go ahead and select for different rights that we can go ahead and give a specific user. But now with 2020, we can go ahead and create these custom profiles in there. So depending on each user, you can go ahead and either add or remove privileges in there. For example, if you're going ahead and having a contractor in, you may want to limit exactly what they have access to. We now also have a few different abilities when it comes to adapting our reports, but the easiest way to see it is through this little video that I have here. But starting off with the user profiles, as you can see, you can go in, have a little look. Got the existing profiles in there. Sure enough, I could go ahead and assign those to someone, but none of them quite meet the requirements that I'm looking for. So what I'm going to do is go ahead and create a new user profile, and you can see from the big list of rights that you can give someone, you can simply check or uncheck the rights that you've given that user. Then all you need to do is go ahead and assign it to them. Moving on to the report side of things for this project that I have open, you can see I've got a little bill of materials here. And it's almost ready to go out, but I want to do a little bit more customization on it. That being that my header just isn't quite big enough. So I'm going to go ahead and adjust the height of that, and I can even go ahead and make it bold. And nice and easily I can also go ahead and change that row height in there for my header. Now, that's not all that I want to do. I'd really like some row numbers for all of my bill of material items. And with SOLIDWORKS 2020, it's now just a simple click of a button to go ahead and add those in, which you can see from the little preview there. Once we've made our changes, we can then go in and update the reports from our project. And then once those have updated, you'll see that all of the modifications that we made now add in. Now, the great thing about the row numbers with this one, guys, is the fact that any changes that we make to the project here on out, anytime we update that bill of materials, all of these row numbers update automatically. We need no manual intervention at this point. So again, just keeping our data secure with our user profile rights and allows customization of reports a little bit easier. Moving over to some schematic delighters, like what Grant suggested earlier on this morning. When it comes to delighters, it's not major enhancements that have been made here. It's just little tweaks that make things a little bit easier for day-to-day applications that you use the software for. And the first one we're looking at here is the leader lines. Now, leader lines are a great way of trying to show what it is you're trying to explain in your schematic in here, whether it be notes or balloons with leaders. But now with this designated tool of our leader styles manager, we can quickly and easily go ahead and add these leaders in, specify the value that we want, and we're done. Again, making it much easier than previous releases. We also now have the ability to go ahead and preview projects within Electrical. Now, up until now, what we've had to do is go ahead and open that project up, and you actually take that project away from another user at that point. So what we can now do is actually open up projects in a read-only mode. That way you're not pulling it away from someone else who's currently working on that project. You can simply review it in read-only and allow them to continue on with the work. We also have a new addition when it comes to archiving our environment in there. And this little addition is excluding projects from your archive environment. Now, you might think this is a little bit of an odd addition, but the main reason for it is if you use SOLIDWORKS Electrical in collaboration with PDM, what you often try to do is constantly have an archived environment, essentially a backup you're trying to create. However, we don't really want to create any duplicated information with our projects in there because you store those in there separately. So what we can now do is go ahead and exclude those projects from our environment archive, and then we're not having any of this duplicated data, and no one's using an older version of a project, that sort of idea. We also have a few little additions when it comes to row marks, table marks, and column marks. Just a few little additions in there so you can customize them a little bit better. And we also have a little change when it comes to the user interface. With that, I mean it's regarding the title block icon. Now, up until now, the title block icon actually stood out a little bit from all of the other icons. So what they've actually done is modified it a little bit, so it actually sits in place now. You'll probably notice it if you upgrade and start to use it from day to day. Second to last one here, we have a little update for Paste Special as well. And what you'll notice by the little red rectangle that was drawn there, we now have this little legend in here. So we can now start to see what exactly is going on with our Paste Special command that we're carrying out with regards to the marks. Are they new ones that have automatically been created? Are they associated already somewhere in the project? Or are they new manual marks that we went ahead and added in there? Again, just makes it easier to see from a glance. And lastly, for delighters, if anyone works on big projects, you'll get the best benefit out of this one, is we've got a performance increase with 2020. So if you're ever working on large projects, you've got multiple sheet schematics, things like that, and you start to find a little bit of lag when you're working away with it, you'll now see with SOLIDWORKS 2020, you'll no longer see this performance drop. It all moves just as smoothly as if you had one sheet in there. But that pretty much covers the schematic side of things. Moving on to the 3D aspects, so electrical 3D and routing. And what we're going to look at is the mass properties for wires and cables in there. Now, for this little example, as Grant put it earlier on this morning, we're actually going to roll back to the model we saw last year because it benefits this option a little bit better. Now, this is a section of the telescope from last year, and what we want to do is go ahead and take into account any cable masses that we have in here, because believe it or not, this telescope has over 4,000 optical cables in it, and the telescope actually needs to be accurate with its angles up to 0.4 decimal places is. So we really need to take these masses into account. So what we can now do is go ahead and define these within our routes, whether it be for cables, wires, coverings, or even partial coverings. And then when we go ahead and jump back to the full model, we can then go ahead and look at our new mass properties in there. That way we have full confidence that our centre of mass is exactly where we expect it to be, and it allows us to get that accuracy of 4 decimal places for our angles in there. That way when we're looking at a star, at least we know we're looking at the star and we're not just looking at black space. Moving on from that, we also have a new addition when it comes to routing in the means of splices. Now, up until now, we've always need to go ahead and add a splice in, add a component in when it comes to a splice. However, that's not always the case in real life. Sometimes these are actually added through a little bit of solder or even welded together. So we can now go ahead and do that with SOLIDWORKS 2020 by simply selecting the No Component Slice option. Now, all we need to do for that one is select the point that we want to go ahead and apply it, and then select that without component. And I'll go ahead and simply represent that in our graphics area by that little sphere that you see in there, not physically adding any component at all. The new little addition as well is we also have the option to create connector blocks in there. So all we need to do is simply right click on one of our end connectors in there, and it'll go ahead and create one of those blocks for us. Now this one links up nicely with our next little option here, where we now have more options when it comes into flatten route. And the option I'm talking about is that connector blocks option in the middle of the screen there. So all those connector blocks that we've actually created from the 3D model can now then be brought through to our flatten route drawings, again making life a little bit easier instead of having to do it manually yourself. Now, another one that can be quite a pain is quite often we've got two teams. We've got our electrical team, sure enough, they go ahead, create all the schematics and things like that, and then we've got our mechanical team. They deal with all our 3D models. Now, the way it generally tends to work is the electrical engineer will hand over the project, goes into the mechanical aspect, and they'll go ahead and add these wires to our 3D model. But with this, we then have no control over our minimum bend radiuses for any of our cables or wires in there. So what we can now do is within SOLIDWORKS Electrical, we can actually go ahead and define this minimum bend radius or even a bend factor in there, depending on which one you enter. It'll calculate the other one for us. That way, when the mechanical engineer takes over, all this information is already within the project, so it's already going to pick up those minimum bend radiuses that we want to follow. Again, just making it a little bit more accurate to what you'd have in real life. But that pretty much sums up the 3D aspect of it, which takes us nicely onto SOLIDWORKS PCB with PDM and even the PDM connector. Now, with SOLIDWORKS 2020, we now have the functionality of working with PCB and PDM internally within the PCB application. We no longer need to use Windows File Explorer in order to do this. We also now have the ability to go ahead and create some reference projects, so it goes ahead and has all those file references in there before we even start anything. And we can even go ahead and, because we're using PDM, follow all those commands that you're used to, the where used, the release process and approvals, that sort of idea. But in the little example we're going to show, we're also going to look at some of these new additions as well, whether it be the advanced layer stack-ups. We can add in split lines and bend lines for any of our PCBs, and we can even go ahead and have a look at the 3D fold in there as well. And all along the way, we're actually going to look at this connector collaboration. If we have a little look at the example. So what we have is this little fan sort of idea here, and at the moment it's missing the PCB from it. So we're going to jump into the PCB application. We can see the board that we want to add in, and what we can do is then go ahead and add this in as a project within our PDM system. And I'm just going to use an existing template to go ahead and create our folder structure that we're looking for. Go ahead and add that in, give it a new name, and it goes ahead and just adds that project in there for me. I can then dig down into my folder structure of my new project, and then start accessing some of the files within there. Now, what you'll notice when I zoom in is all the information has updated with the new project name that we added in there. And then once we're happy, we can then go ahead and push that through to the mechanical team. Now, at the moment, you can clearly see that PCB is not going to fit in the way it is. We actually want to add in a little bit of a bend. So we're just going to add in a little bit of a note, and we're going to go ahead and push that back to the PCB application. The electrical team can then take it back up again, have a little look at the recommendations that the mechanical team have made, then we can go ahead about making those changes, selecting a region that we want to go ahead and make flexible, so say the middle section of that PCB. Then we can go ahead and add in those bend lines in there as well. We can go ahead and add in our bend angles and our bend radius in there as well. We can go ahead and add in one more bend line. And again, we're just going to fill out the information in the same manner as well, adding in that bend angle and the bend radius. We then get a 3D preview of what that looks like. And then once we're happy, we can go ahead and push that back to the mechanical team again. Sure enough, changes have been made. We can go ahead and accept the changes, bring it into our new model, and then take that into our assembly. Now sure enough, you can see there's a bit of a design flaw here. The angle isn't quite right. So the mechanical team can even go ahead and modify that angle. Now, not only that, again, we can then go ahead and push this back to the electrical engineer and make sure that this modification is going to be okay on their end as well. Again, we can go ahead and pull through the modifications that have been made and ensure that it's going to suit. We can then create any publications that we want to make from this project. And then finally, what we're going to do is go ahead and store this away in our PDM vault. Again, as we mentioned, we can do this directly from within the PCB application. Just check it in. And then, just like you would with any other file within PDM, we can then go ahead and start pushing this through our workflow in order to get approved and so on. And what you'll notice is we even get these, we can even go ahead and rev up these files as well. That pretty much covers the PCB section of our enhancements.